Welcome to Tabletops. So we are still moving on with coordinate geometry, and another example still goes, find the equation of the line passing through the following points and perpendicular to the lines. Part A, 3, -2, perpendicular to 3x minus 2y plus 5. From part B, 4, 6, perpendicular to 2x minus 5y minus 6 equals 0. Then for the case of Roman design, find the equation of perpendicular bisector of the line AB, where A is that and that B is 1, 5. So what we're going to do, we are getting solution to Roman 1, to solution for Roman 1 part A, which goes, we've got the point is 3, -2 and perpendicular to 3x minus 2y plus 5 equals 0. Still from that line, we are supposed to express it in terms of y equals mx plus c. So what we're going to do, we are going to have 2y equals 3x minus 5 plus 5. So can we make y alone? Y is the same as 3 out of 2x plus 5 out of 2. Then we also say comparing with y equals mx plus c. So what is the gradient m? So our gradient m is 3 out of 2. You can say this is the gradient m1. And we say for perpendicular bisector, m1, m2 must give us -1. Do we know m1? M1 is already 3 out of 2. M2 now equals -1. Can we make M2 the subject? So M2 will be -2 out of 3. So that's what we call our M2. Now we have already got our point. Our point is already, can call it A, which is 3, -2, and I can call another point P, X and Y. How do we get the gradient of this? We shall say gradient is given as change in y over change in x, which becomes y plus 2 over x minus 3, which is equal to -2 out of 3. Because they said it's perpendicular, that's why we're equating to that. Can we try to cross multiply? We're having -2 into x minus 3, which is equal to 3 into y plus 2. Can we open? We're getting -2 into x minus 3 into y plus 2 equals 0. Can we open this? -2x plus 6 minus 3y minus 6 equals 0. So we are remaining with -2x minus 3y equals 0. If we divide out by a negative, we shall probably remain with 2x plus 3y equals 0. That's what we can do when it comes to that. What is important from you is express the given line in terms of y equals mx plus c. Then from there, again, after getting the gradient, then bring the condition that we say that for perpendicular, the gradient of the tangent times the gradient of the normal, they equal to -1. So we are going now to solution for Roman 2. Solution for part A, but Roman 2. So we are going to solution for Roman 1 part B, saying that the point is 4, 6, still perpendicular to 2x minus 5y minus 6 equals 0. So we are going to express that line in terms of y equals mx plus c. What are we going to have? We are going to have 5y equals 2x minus 6. So what is y alone? Is 2 out of 5x minus 6 out of 5. Then we say comparing with y equals mx plus c. So what can we compare? So we are having gradient m1 equals 2 out of 5. This one here, which is like the gradient of the tangent. Then we say that for perpendicular, M1, M2 must give us a -1. Do we know our M1? Our M1 is already 2 out of 5. We say 2 out of 5. M2 equals -1. So what is M2 alone? Is -5 out of 2. That is our M2. Then from there, we are going to get our point, which is 4, 6. Can you call it point B? Together with point P, you can call it point P line on that line. So we get the gradient of the line ABP. How do we get the gradient here? So I'll say change in y, which is y minus 6 out of x minus 4, which is equal to -5 out of 2. Can we cross multiply? We are getting -5 into x minus 4, which is equal to 2 into y minus 6. So can we bring this? We are getting -5 into x minus 4 minus 2 into y minus 6 equals 0. So we are getting -5x plus 20 minus 2y plus 12 equals 0. So we are getting -5x minus 2y plus 32 equals 0. Dividing throughout by negative, we are getting 5x plus 2y minus 32 equals 0. This is what you can do when it comes to such kind of the questions which are in that way. So we are now moving to part Roman 2 of the question. Part B goes, find the equation of the perpendicular bisector. Find the equation of the perpendicular bisector. Find the equation of the perpendicular bisector of the line AB with A is that. So if you have point A, as 3, 1, and you have point B as 1, 5. So how do we get the equation of the perpendicular bisector? The one which is bisecting this line. Can even look at this. This one is bisecting it. And bisects through the midpoint. So if this is our point P, X, and Y, so this is the line which is bisecting that line. So the first step is we need first get the midpoint of the line AB. So can we get the midpoint of AB? And we said the formula of midpoint was given as x1 plus x2 by 2, comma, y1 plus y2 by 2. So what is our x1? Our x1 is 3 plus 1 out of 2, comma. What is y1? Y1 is already 1 plus 5 by 2. So what does it become? 3 plus 1 you are getting a 4, and 4 divided by 2 you are getting a 2, comma. 6 divided by 2 it is a 3. This is the midpoint. So we need now also to get the gradient of the line AB. So can we get gradient of M1 of line AB, gradient M1 of AB, which is y2 minus y1, which is given as y2 minus y1 over x2 minus x1. Our y2 is already 5 minus 1, and our x2 is 1 minus 3. 5 minus 1, we are getting a 4 out of -2, which becomes -2. This is M1. Then we say for perpendicular, M1, M2 must give us -1. So do we know M1? M1 is already a -2. So we get -2, M2 equals -1. So can we make M2 the subject? So M2 becomes +1/2. Then from there, we are using this very point here, because this one is going with that. Our point is M, which is already 2, 3, together with point P, which is x, y. So can we get the gradient of this? So to get the gradient, we are going to equate that one. Then at the end, we shall come out with an answer. We shall say y minus 3 out of x minus 2 equals a half. We try to cross multiply and we come to the conclusion of it. So when you cross multiply, we are getting x minus 2 equals 2 into y minus 3, which becomes x minus 2 into this minus this equals 0. So we are getting x minus 2y plus 6 equals 0, which becomes x minus 2y plus 4 equals 0. So this one becomes the equation of the perpendicular bisector passing through the points A and B.